In section 11.2, we will look at surface area of prisms and cylinders. A prism is a 3D figure with exactly two congruent parallel polygonal faces. Bases are the two congruent parallel faces of a prism. And in our triangular prism on the right, our two bases are triangle ABC and triangle DEF. Lateral faces are the parallelograms or rectangles that make the other faces. So again, in our triangular prism on the right, our lateral faces are rectangles ADFC, ADEB, and BEFC. The altitude is the perpendicular segment that joins the planes of the bases. The height is the length of the altitude. Lateral area is the sum of the area of the lateral faces, and we can use the formula that lateral area equals P times H, where P is the perimeter of the base, and H is the height. Surface area is the sum of the lateral area and the area of the two bases. We can use this formula that surface area equals lateral area plus 2 capital B, where capital B is the area of the base. In number 1, we want to find the lateral area of the prism and the surface area of the prism. So our figure on the right is a triangular prism. Where our bases are triangles. So that means for the lateral area, we will find the perimeter of our triangles times the height. So for A, our lateral area will be perimeter of the triangles. So that's 5 plus 5 plus 6, and then times the height of our triangular prism, which is 12. So our lateral area is 16 times 12, or 192 centimeters squared. Okay. And then to find the surface area, so part B, we'll take our lateral area, which we just found to be 192, plus 2 times capital B. Remember, capital B is the area of our bases, which in this case they're triangles. So capital B will be 1/2 times base times height. Well, our base of our triangle is 6. Now to find our height, so that would be this line segment here, we'd have to use the Pythagorean theorem. where this side's 3, our hypotenuse is 5, or you can remember it's a Pythagorean triple, so our height is 4. So then surface area equals 192 plus 2 times 12 or 192 plus 24. So our surface area is 216 centimeters squared. All right, number 2, we want to find the lateral area of the cube and the surface area of the cube. Now remember, a cube has a square base. So our lateral area will be the perimeter. So there are 4 sides, and they're each 11 inches, times the height, which again is 11 since it's a cube. All our sides are congruent. So our lateral area, 44 times 11, or 484 inches squared. And then for part B, the surface area, so that will be our lateral area, which is 484, plus 2 times the area of our base, and since our base is a square, that would be length times width, or 11 times 11. So our surface area, 484, plus 2 times 121, or 484 plus 242. So our surface area is 726 inches squared. In number 3, we want to find the lateral area of the octagonal prism and the surface area of the octagonal prism. So we have octagon bases. Alright, so for part A, our lateral area, so perimeter of the base, so perimeter of our octagon, since it's a regular octagon, there are 8 sides, and they are 5 centimeters each, times the height, which is 22 centimeters. So our lateral area, 40 times 22, or 880 centimeters squared. Forgot the 0. Okay. And then for part B, we want to find the surface area. So our lateral area plus 2 times the area of the bases. Now, area of our bases would be the area of a regular octagon. So remember, a regular octagon, we're going to use that formula 1/2 apothem times perimeter. So if I draw in the center of my octagon, draw in the apothem and the radius, I have a right triangle. each of my angles I would have to find by taking 8 minus 2 times 180 divided by 8. So each of my angles in the regular octagon are 135 degrees. So that's these angles here. Now when I draw in my right triangle, that splits that angle in half. So my angle in my right triangle is 67.5 degrees. Now that's not a special right triangle, but if I know this angle and this side's now 2.5 and I want to find A, I'll have to use one of my trig functions. So I know the angle measure and the side adjacent to it. I want to find the side opposite. That would be tangent. So tangent of 67.5 equals opposite over adjacent. And then solving for A, our apothem, we get about 6.0. Alright, now we can find the area of our regular octagon. So 1/2 times 6 times the perimeter, which we found in part A to be 40. So our area for the regular octagon is 120 centimeters squared. So now I can plug that into my surface area formula. So surface area 880 plus 2 times 120. So surface area equals 880 plus 240. Or 1,120 centimeters squared. Now to look at cylinders. A cylinder is a 3D figure with two congruent circular faces. The bases are the two congruent parallel circular faces. The altitude is the perpendicular segment that joins the planes of the bases. The height is the length of the altitude. The lateral area is the area of the rectangle that makes the body of the cylinder. So to find the lateral area, we would take 2 times pi times r times h, where r is our radius and h is our height. And to find the surface area, we would take the sum of the lateral area and the area of the two bases. Again, where r is the radius and h is the height. So in our cylinders on the right, our radius would be from the center of the circle to the edge, so there's our r, and then this would be our height, perpendicular segment between the two bases. Cylinder here, here's our radius, so each circular base has a radius, and then our height would be this perpendicular segment joining the two faces or the two bases. In number 4, the radius of the base of a cylinder is 6 feet and its height is 9 feet. Find its surface area in terms of pi. So I'm just going to label that we have our radius of 6 feet and our height of 9 feet. And now we're just going to substitute into our surface area formula. So remember, surface area 2 times pi times our radius times our height. Just fix my pi. Plus 2 times pi times our radius squared. All right, then we simplify. So we have 2 pi times 54 plus 2 pi times 36. Okay, and then simplify again. So we can take 2 times 54, or 108 pi, plus 2 times 36, or 72 pi. Now it said to leave in terms of pi, so I can just add my like terms to get 180 pi feet squared. Okay. In number 5, it says find the surface area of a cylinder with height 10 centimeters and radius 10 centimeters in terms of pi. Okay, so our radius is 10 centimeters and our height is 10 centimeters. So using that same formula, so surface area equals 2 pi times the radius times the height plus 2 pi times the radius squared. So surface area equals 2 pi times 100 plus 2 pi times 100. So simplifying again, we have 200 pi plus 200 pi. Again, we're going to leave in terms of pi. So we're going to combine our like terms. We have 400 pi centimeters squared. Number 6 says a company sells cornmeal and barley in cylindrical containers. The diameter of the base of the 6-inch high cornmeal container is 4 inches. The diameter of the base of the 4-inch high barley container is 6 inches. Which container has the greater surface area? All right, so let's find the surface area of the cornmeal first. Where our radius is 2 inches, because it said our diameter was 4, and our height is 6 inches. All right, so surface area will equal 2 pi times radius times height plus 2 pi times radius squared. Just fix that too. Go. So surface area equals 2 pi times 12 plus 2 pi times 4. So simplifying, we have 24 pi plus 8 pi. Oops, yeah, we're good. Or 32 pi inches squared. And I'm just going to leave my answers in terms of pi since we're just comparing the two to see which one has a greater surface area. And let me just fix my units there. Okay, now let's find the surface area of the barley. All right, so our radius is 3 inches, half of our diameter, and our height is 4 inches. So surface area equals 2 pi times radius times height plus 2 pi times radius squared. So surface area equals 2 pi times 12 plus 2 pi times 9. And then combining like terms, we get 24 pi plus 18 pi or 42 pi inches squared. Okay, so then that tells us that the barley container has a greater surface area. All right, our last example in this section, number 7, says the drums of the roller at the left, well, guess we have no picture here, oh well, are cylinders of length 3.5 feet. The diameter of the large drum is 4.2 feet. What area does the large drum cover in one full turn? Round your answer to the nearest square foot. So we are looking to find the surface area of the drum to see what kind of area it covers. That would be the area of the whole cylinder. All right, so our radius is 2.1 feet, half of our diameter, and our height is 3.5 feet. All right, so surface area equals 2 pi times radius times height plus 2 pi times the radius squared. All right, and let's simplify. So we have 2 pi times 5.6 plus 2 pi times 4.41. And then simplifying again, we have 11.2 pi plus 8.82 pi. Combining like terms, that's 20.02 pi feet squared. And it's said to round to nearest square foot. So that means we're rounding to the nearest whole number. So take 20.02 times pi. You get your surface area is about 63 feet squared. So that's how much area that our cylinder would cover.